In this video, we are going to connect the check your understandings from the previous video and talk about conditional probability. In the last video, we talked about this idea of conditional probability and this word given. And we did problem 10 and 11. And when you think of given, think of the sample space is changing. We also, in that video, looked at these two formulas. We already know this first formula because we learned it a couple lessons back, but we haven't seen this second formula. As we discussed previously, these are the same. They have the same variables. They're just solving for a different variable. So this one on the left is solving for the probability of A and B. This one on the right is solving for the probability of B given A. This one on the right is called conditional probability. Conditional probability is the probability of event B, assuming event A has already occurred. And we'll use the notation probability of B given A. This vertical line here is given. It's not a division sign. And there's different ways to think about conditional probability, and it's going to depend on the problem whether or not you use this following formula. The probability of B given A equals the probability of A and B all divided by the probability of A. Now, just a little preface, as you start going through these problems, it'll get easier. I know it's a lot of notation and it seems harder when we're using division, but just keep practicing it. It will get better. So let's look at some problems. You are dealt only one card from a 52 card deck. Find the probability of a jack given the card was a face card. All right, let's go ahead and look at the deck of cards just for a quick moment. This problem says given it was a face card. That means we're only dealing with this. Let's say I had a deck of cards and I drew a card and I'm going to have you guess it. And if you guess it, I'll give you $5. But as I say, guess what card I have, I say, I'll give you a hint. It's a face card. So now guessing what that card is becomes a lot easier. Our sample space has changed. We no longer have 52 cards. We just have 12. And of those 12, how many are jacks? 4. So let's write this all down. This wants the probability of getting a jack given the card was a face card. When I see the word given, everything after given is usually a different sample space. So probability of jack given face card, this will equal, well, we had 12 face cards. And how many of them were jacks? 4 of them were jacks. So the probability of being a jack, given that a face card was drawn, is 1/3. And let's just add a note in here. This is the sample space after the word given. Let's look at the next problem. You are dealt a heart card from a standard 52 card deck. Without replacing that card, that means we draw a heart and we put it aside. And now our deck has changed. You are dealt a second card. Determine the probability that the second card is a red card. This time I'm going to do it mathematically and then we'll go to the deck of cards. Okay, we want to find the probability that the second card is a red card given the first card was a heart. Now, since we are drawing 2 cards here, we can't use our little trick of everything after given tells us our sample space. For this problem, it says we are dealt a heart first and it is removed from the deck. So now we only have 51 cards in the deck because we've removed that heart. Then it says find the probability that the second card is a red card. Well, there are 26 red cards, but we removed a heart, which is also a red card. So this becomes one less, which is 25 51st. Let's go ahead and look at the deck of cards to show that visually. The problem says that the first card is a heart. It doesn't matter which heart we cross off. So I'm just going to cross that one. Now we want to find the probability of being a red card. Well, there is now 25 red cards out of our deck of 51 cards. Because when we removed that first card, we changed our sample space. One thing to keep in mind is this is not asking for the probability that the first card is a heart and the second card is red. If that was being asked, then we would multiply the two probabilities, but we're just trying to find what is the probability of the second card. Now we're going to practice using the formula, and I know you can reason your way through it, or you can go back and look at the previous problems when we did it, but I do want to show you how to use the formula. As a refresher, let's go ahead and read through it. Your friend offers you a brownie that she's made in one of her classes. She has 10 with nuts, 15 without nuts. We are going to remove 2 brownies in succession. So our sample space is changing when we remove that first one. So that tells us that we're dealing with dependent events. Maybe we're going towards a conditional probability type question. The probability that the first brownie doesn't have nuts is 3/5. Okay, so let's go ahead and write down the probability of event A is going to be 3/5. This is the probability that the first has no nuts. Then the next part says the probability that the first brownie doesn't have nuts and the second brownie doesn't have nuts is 7/20. The word to focus on is and. So let's write all those words in math notation. So the probability that the first has no nut and the second has no nuts is going to be 7/20. Or we can rewrite this as probability of A and B equals 7/20. Now it's asking us, what is the probability that the second brownie doesn't have nuts given the first brownie doesn't have nuts? So we want to find the probability that the second brownie doesn't have nuts given the first doesn't have nuts. Let's change this to A's and B's. So this will be probability of B given A. This is the thing we don't know. Now I can use my formula. The formula is the probability of B given A equals the probability of A and B all divided by the probability of A. Okay, so this will be 7/20 that we get from right here divided by 3/5, which is this value right here. Now, all we have to do is simplify that. So just as a reminder back from your fraction days, this is a division sign divided by. So I can rewrite this as 7/20 divided by 3/5. This is going to be the same as 7/20 times 5/3. And this will give me 35/60, which simplifies to be 7/12. Now, let's compare this to problem 9 from several lessons back. So here is problem 9, and this is the answer to the same problem, except for one we approached using the tree diagram, and the second one we approached using the formula. Either way will work. The reason I did it this time with the formula is to give you experience with that formula. Okay, let's do one more problem. David is applying for a corporate job and determines that he has an 88% chance of being hired. So probability of being hired is 0.88. I'm going to turn it into a decimal so that we can put it into our calculator. He knows that 29% of all applicants get hired and are given a private office. So probability of hired and office. That's going to equal 0.29. Let's go ahead and come in here and give it some notations of A's and B's. So this is probability of A, and this will be probability of A and B. Now the question is saying, what is the probability of David getting a private office given that he gets the job? Okay, we're looking for a probability of an office given he gets the job. Let's put some A's and B's in here. Probability of B given A. This is the thing right here that we don't know. So probability of B given A is going to be the probability of A and B over probability of A. Well, we have the probability of A and B, that's our 0.29. And we have the probability of A, which is our 0.88. Now, we can't leave this as a decimal in a fraction because that's mathematically awkward. So put that in your calculator and you get 0.3295. This is going to be the probability of getting a office given that he gets the job. In the past 2 lessons, we've learned a couple of ways to handle this conditional probability. For some, we can kind of think through it and kind of imagine a deck of cards or a die or a table full of brownies. And with that, sometimes after the word given, we can kind of think of the changing sample space. For other problems, we are going to have to use that formula. Try some of these techniques on the practice problems that follow.